Hey there fellow programmers, welcome back to our channel. Today we are seeing towers problem from CSES problem set. In this problem we have given n cubes in a certain order. We're tasked to build a tower using them. Whenever two cubes are one on a top, the upper cube must be smaller than lower cube. You must be process cube in a certain order. You can always enter the place of the cube on the top of the existing or being a new tower. What is the minimum numbers of possible towers? So, and we have a condition, we upper cube must be smaller than lower cube. That means suppose we have a cube a4, then the upper cube is less than 4, that like 3. Okay, now we'll check for the problem. We have a given problem 3 8 2 1 5. Now we want to build a tower from it. When first element 3 come, we write down, then the next element 8 can't place top of the 3, we will write down the next 2. We have two towers setup. When 2 comes, we have two option, we can place at the top of the 3, and we can place at the top of the 8. Suppose we can place at the top of the 2, sorry, the top of the 3, and we can place at the top of the 2. When 1 come, we have also two option, we can place at the top of the 1 or 2, and second option is we can place it at the top of the 8. Same for it, we can place it top of the 3, we can, and second option is we can place at the top of the 8. Now 5 is come, we can place the 5 at the top of the 8. That's mean 3 2 1 8. 3 2 1 8 5. That's we have 2 towers. Now for it, we can't place anywhere, we can build new tower. That's mean we have 3 towers. For this same, we can't place 5 at anywhere, so we write down we have 3 towers. Same for it, we can't place tower at anywhere, so we can write down new tower. That's mean we have 3 towers. The minimum towers are possible are 2. From the previous process, we have a conclusion. When a new element come, if their upper max is present, then we will use the nearest possible max. Otherwise, we create a new tower. Suppose for 3 we don't have any element, we can create new tower. For 8 we don't have any upper max tower, so we'll create one more tower. For 2 we have a upper nearest tower is 3. That's mean we put 2 cube on a 3 cube. Then we, for 1 we check upper nearest are 2. That's mean we will place here. For 5 we can't place it here, so we'll check upper nearest 8. That's mean 5. We have 2 towers. I think you got idea. Let's see how we can build our code by using this approach. For the code explanation, we will check when the first element come, we write down in a new array. Then second element, when second element came, we will check the nearest max element of the nearest max element of that element. We don't have for it. For 2 we will check the nearest max, that is 3. We write down the at the 2 at a 3. Now for 1 we check the nearest max 1, we'll write down 1 at a 2. Now for 5 we'll check nearest max 8, we'll write down here. Now we have only 2 towers. That's mean our answer is 2. To find nearest max in previous array, we will use the upper bound method. Let's see our code. Let's code it, guys. First I will take n numbers of cubes, then I will create multi set, sorry, to create multi-set. Okay, we have multi-sets is the tables. Now run for loop from I to n. Then I will take input cube size. Now I will check the upper nearest upper element, nearest upper table, sorry. Now I will check nearest upper tower is present. Now I will check nearest top of the tower is present. Dot t dot begin, t dot end. If the t dot end is the if it is if the upper bound of the cube is not present, if the upper bound of the cube is not present, then we will insert the cube in the multiset. Otherwise we erase the previous top of that cube, like t dot erase it, and we will insert new cube like this. When three size cube are come, we will check if the any cube present in greater than it, not, that's mean we'll insert it. For it we'll check any cube is greater than it present, not, that will insert. For 2 we'll check any cube is greater than, yes, we have a 3, that's mean we erase 3 and we insert 2. We can erase 3 and we will insert 2 for 2. For 1 we will same, we have a greater than, yes, 2, we erase 2 and we will insert 1. For 5 we have a upper, if 8 we will erase 8, we insert 5, that's mean our answer is 1 and 2. We will print the size. Now t dot size, our size are 2, sorry. Tower size are 2. Our test cases are passed. Let's submit it. Accepted. Thank you guys.